Let's continue off of our last video and dive a little bit deeper into our atmosphere. So as a quick definition, the atmosphere is kind of the blanket of air and water vapor or moisture that surrounds the Earth. It's very important for life and keeps our weather systems intact. It extends approximately 500 kilometers upwards, after which we kind of start to define where space begins. So what is the atmosphere? It's made up of several gases. The air in our atmosphere is primarily composed of nitrogen, and we're looking at about 78%, and then oxygen, 21%. The numbers do vary slightly depending on the source and how they're rounded. Argon and carbon dioxide are also relatively common, while the final portion, less than a percent, about 0.04%, is made up of other gases such as neon, helium, methane, and ozone. Depending where you are, you might find more water vapor, or you might find sulfur dioxide if you're in a highly polluted area. Do note that this figure is quite old. The CO2 concentration has now surpassed 0.04%. So let's focus a little bit on CO2 or carbon dioxide. Greenhouse gases, which carbon dioxide is one of, it's a class of gases. It's very present in our atmosphere, although the percentage is quite low, it is quite potent. And there are kind of negative repercussions to that. Greenhouse gases in general, including carbon dioxide, are very good at absorbing radiation and heat, and that's why we've seen a general rise in average temperatures on Earth as the amount of carbon dioxide in our atmosphere has increased. As of recording this video, the current concentration of carbon dioxide in the atmosphere is about 415 parts per million. That does change daily, but that number is quite concerning. The quote safe limit is considered to be around 350 parts per million. Over the last few years, we've hit 400 and we've surpassed that. You can check out the website co2.earth for a daily update of what the current concentration of carbon dioxide is in our atmosphere. But the general goal is to get it below 400 and below 350 if possible. So why is the atmosphere important and why do we focus on it so much? Well, the atmosphere does have what we call a natural greenhouse effect. And that's, we have extreme temperatures. It warms the Earth's surface. It reduces extremes. We have the ozone layer, which protects us against damaging ultraviolet radiation from the sun. The ozone layer is quite an interesting topic because it was in danger several years ago. It started to degrade, and we have since then actually been able to fix it. And then, some other parts in the atmosphere, oxygen gas, O2, carbon dioxide, CO2, and H2O water, they're all necessary for survival. They're part of the water cycle, the carbon cycle. Humans breathe in oxygen and exhale carbon dioxide. Plants use carbon dioxide and then they produce oxygen. And of course, all living things on Earth do require water. If we take a look at the atmosphere, we have these kind of air currents, or what we're going to call convection cells, and they force warm, moist air to rise at the equator and cool, dry air to sink at the poles. Heat, energy, and moisture is then transferred around the globe from pole to pole. And so all of this kind of is a delicate balance in our atmosphere, all these different components working together to try to keep the planet at a reasonable temperature. So finally, we have all these layers to the atmosphere. These layers they all have different names, and where they are located kind of defines what they're made up of. So at the bottom, we have the troposphere, which is between 6 and 20 kilometers in altitude. It's got most of the atmosphere's moisture. What we define as weather kind of takes place in the troposphere. The stratosphere, we're now trying to get a little bit higher. That's where the quote ozone layer is, and generally where planes fly. The mesosphere, meso meaning middle, we're like 50 to 85 kilometers up. That's where meteors tend to burn up. The thermosphere is up to just under 700 kilometers, and that's where we see the northern lights, aurora borealis, where space shuttles might orbit. And then way above that, close to 700 kilometers plus, we're talking about the exosphere, and that's where we see satellites orbiting. So those are all the parts of the atmosphere and kind of how they work together to help regulate the temperature on Earth.